Okay, now let's start about the properties of rational numbers. The first property is the closure property. The property states that if we perform any operation like addition, subtraction, or multiplication or division on any two elements of a set, then the result will always be an element of the same set. Here set means natural number set, whole number set, integer set, or rational number set, any of that. So, performing any operation like addition, subtraction, or multiplication and division on any two natural numbers will result in natural number. Then it performs the closure property. So, let's check the whole numbers first. First, addition. If we add two whole numbers, is the sum equal to the whole number or any other number? Let's check it. First, let's check about 0 plus 8. 0 plus 8 is 8. 0 and 8 are both whole numbers and 8 is also a whole number. So, this is correct. Next, 4 plus 5 is equal to 9. 4 and 5 are both whole numbers and 9 is also a whole number. So, this is also correct. Then, addition is undergoing closure property and it is closed under whole numbers. Then let's come to subtraction. In subtraction, let's take 7 and 9. 7 minus 9 is minus 2. 7 and 9 are whole numbers, but minus 2 is not a whole number. So it does not follow closure property. So subtraction is not involved. Then comes the multiplication. Let's try. 0 into 3 is 0. Anything multiplied by 0 is a 0. So 0 and 3 are both whole numbers and 0 is also a whole number. So it is performing. Yeah. The next, let's try next one. 7 into 5 is equal to 35. 7 and 5 are whole numbers and also 35 is also a whole number. So multiplication is closed. Okay, then comes the division. Let's divide 5 and 8. 5 by 8. Let's see. We can't divide this. So, it is in the form of p by q. It is a rational number, not a whole number. So, 5 and 8 are whole numbers. 5 by 8 is not a whole number. So, it does not follow closure property. So, in whole numbers, what we got to know is that only addition and multiplication follows closure property. So, as we have checked, addition and multiplication follows closure property. And for the natural numbers, it is also same. Only addition and multiplication follows closure property. Now, let's see integers. First, for addition, let's add the two numbers. Minus 1 and 8. We get plus 7. When both signs are different, we will subtract and we will subtract first. 8 and 1 subtraction is 7 and we will put the sign of the bigger number plus 7. So, minus 1 and 8 are integers and 7 is also an integer. So, it follows closure property. The next one is minus 9 plus 4. Here also we will do subtraction and put the sign of the larger number. So, minus 5. Minus 9 and 4 are integers, but minus 5 is also an integer. So, it follows closure property. This next, we got to know addition is right. Then we will check for subtraction. Minus 1 and minus 5 is equals to minus 6. Here both signs are same, so we will add. 1 plus 5 is 6 and we will put the same sign here. So minus 6. Minus 1 and 5 are all integers and minus 6 is also an integer, so it follows closure property. The next one is minus 6 minus 1. Minus 6 of minus 1. Minus into minus is plus. So minus 6 plus 1. Minus 6 plus 1 is minus 5. Sorry, this is the mistake. Minus 5. So minus 5 is also an integer. Minus 6 and minus 1 are also integers. So it follows closure property. and subtraction is followed. Then multiplication. 5 into minus 2 is minus 10. We will multiply the numbers and put the sign as it is, as plus into minus is minus 10. 5 and minus 2 are integers and minus 10 is also an integer, so it follows closure property. The next example, minus 1 into minus 6. Both signs are minus. Minus into minus is plus. 6 into 1 is 6. So minus 1 and minus 6 are integers. So 6 is also an integer, so it follows closure property. Multiplication is followed. Then the division. Let's check for minus 5 divided by 8. Minus 5 by 8, it is in the form of p by q. So it is an rational number, not an integer. So minus 5 and 8 are integers, but minus 5 by 8 is not an integer and division is not followed. So in integers, addition, subtraction and multiplication is followed under closure property. And let's revise it once again. If a and b are integers, a plus b, the addition is under followed closure property. So a plus b is also an integer, a minus b is integer, a into b is also an integer. For whole numbers, only addition and multiplication is followed under closure property. So a plus b is a whole number and a into b is a whole number. Same goes for natural number. Let's see rational numbers. First, look at the addition. First example, 5 by 3 plus 2 by 3. Here denominators are same, so write it as it is and add the numerators. 5 plus 2 is 7. So 5 by 3 plus 2 by 3 is 7 by 3. Both 5 by 3 and 2 by 3 are rational numbers and 7 by 3 is also a rational number, so it follows closure property. The second example, minus 3 by 5 plus 8 by 3. So here how to add these? The LCM of 5 by 3 or multiplication of 5 by 3, 5 into 3 is 15. So 5 3s are 15, 3 3s are minus 9. Minus is as it is, 3 3s are 9. 3 5s are 15, 5 8s are 40. Minus 9 plus 40 is subtraction and putting the larger number sign, plus 31 by 15. So minus 3 by 5 and 8 by 3 both are rational numbers and 31 by 5 is also a rational number, so it follows closure property. The next example, minus 3 by 8 plus of minus 4 by 5. So here first let's write down the denominator. 8 5s are 40, 8 5s are 40, 5 3s are 15, minus is there, minus 15. 5 8s are 40, 8 4s are 32, minus is as it is and the plus sign is written as it is. Here plus into minus is minus, so minus 15 minus 32 we should add. So 47 and the minus sign, minus 47 by 40. So now minus 3 by 8 and minus 4 by 5 both are rational numbers and minus 47 by 40 is also a rational number, so it follows closure property. The next example, 4 by 7 plus 6 by 11. Here let's see, 7 into 11 77, 7 11s are 11 4s are 44. 11 7s are 7 6s are 42. So if we add this, 86 by 77. So 4 by 7 and 6 by 11 are both rational numbers and 86 by 77 is also a rational number, so it follows closure property. So addition is followed. The next is subtraction. Let's see, 8 by 5 minus 2 by 5. Here denominators are same, so we can subtract the numerators directly. 8 minus 2 is 6. So 8 by 5 minus 2 by 5 is equals to 6 by 5. 8 by 5 and 2 by 5 are rational numbers and 6 by 5 is also a rational number, so it follows closure property. Let's see another example. Minus 5 by 7 minus 2 by 3. So here 7 3s are 21. 7 3s are 3 5s are minus 15. Minus as it is, 3 7s are 7 2s are 14. Minus 15 minus 14 is minus 29 by 21. So here minus 5 by 7 and 2 by 3 are rational numbers and minus 29 by 21 is also a rational number, so it follows closure property. The next example, 5 by 8 minus 4 by 5 is equals to 25 minus 32 by 40. How it become? 8 5s are 40, 8 5s are 5 5s are 25. 5 8s are 8 4s are 32. 25 minus 32. We are subtracting 32 minus 25 is 7 and putting the larger number sign minus 7 by 40. So 5 by 8 and 4 by 5 are rational numbers. Minus 7 by 40 is also a rational number. So it follows closure property. The next example, 3 by 7 minus 8 by 5. Here 7 5s are 35. 7 5s are 5 3s are 15 minus as it is 5 7s are 7 8s are 56. Here this minus is also written as it is. So it will become plus. If we add both, we will get 71 by 35. So here 3 by 7 and a minus 8 by 5 are both rational numbers and 71 by 35 is also a rational number. So it follows closure property and subtraction is followed. Let's move on to multiplication. Here multiplication, let's see, minus 2 by 3 into 4 by 5. Here we will multiply both numerators and keep it as numerator and multiply denominators and keep it as denominator. So 4 2s are 8, 5 3s are 15. So minus 8 by 15. Here also minus 2 by 3 and 4 by 5 are rational numbers and also the product minus 8 by 15 is also a rational number, so it follows closure property. The next one is 3 by 7 into 2 by 5. 3 2s are 6, 7 5s are 35. It also follows closure property as it is also a rational number. These both are also rational numbers. Next one is minus 4 by 5 into minus 6 by 11. Minus into minus plus 6 4s are 24, 5 11s are 55. Minus 4 by 5 and minus 6 by 11 are rational numbers. And the product 24 by 55 is also a rational number. So it follows closure property. Multiplication is. Okay, let's move on to division. Let's divide minus 5 by 3 and 2 by 5. When dividing the rational numbers, we will write the first term as it is and we will put the multiplication sign and reverse the second number. So 2 by 5 becomes 5 by 2. So now we will get the product of these two numbers. 5 into 5 is 25, 3 2s are 6, minus 25 by 6. Here also minus 5 by 3 and 2 by 3 are rational numbers, minus 25 by 6 is also a rational number. Here it follows closure property. The next example, 2 by 7 divided by 5 by 3. Add the 2 by 7 as it is and reverse the 5 by 3 as 3 by 5 and product 3 2s are 6, 7 5s are 35, so 6 by is 35. So 2 by 7 and 5 by 3 are rational numbers, 6 by 35 is also a rational number, it follows closure property. Let's know the next example, minus 3 by 8 divided by minus 2 by 9. Here also minus 3 by 8 into 9 by minus 2, minus minus is cancelled, 9 3s are 27, 8 2s are 16, 27 by 16. Minus 3 by 8 and minus 2 by 9 are rational numbers, 27 by 16 is also a rational number, so it follows closure property. But we have to check all the rational numbers. So if we check for 0, if a is a rational number and a divided by 0, if we do a by 0, it is not defined. So when it is not defined, it does not belong to rational numbers or any other number set. So rational numbers are not closed under division. So rational numbers are only closed under addition, subtraction and multiplication. So let's revise it to know that if a and b are rational numbers, then a plus b, a minus b and a into b are rational numbers, but a divided b is not a rational number. Let's move on to the exercise given in the textbook. Fill in the blanks for the following table. For the rational numbers, as we saw, addition, subtraction and multiplication is closed, but division is not closed. And for integers, it is same. Addition, subtraction and multiplication is closed, but division is not closed. But for whole numbers and natural numbers, only addition and multiplication is closed and subtraction and division are not closed. Okay, thank you.